All right, so now we're wanting to get into our house and we have to go through 2 doors. So like first you pass through the lobby door and then you get up to your actual door and you have to open that. So the probability that the first door is unlocked is 4/5. So this makes sense. Maybe the guard is there most of the time and it's typically unlocked. So we have our first door. So I'm going to make myself some tree diagram branches. So it's either unlocked, All right. So either we have unlocked or we have locked. So I'm going to use L for locked. So if it's the probability of it being unlocked is 4 out of 5, that means the probability of it being locked must be 1 out of 5. Now we have a conditional statement. If it's unlocked, then the second one being locked is 1/4. So if the first one is unlocked, that's this set of branches. The second one is either unlocked or locked, and we're told that the second one being locked is 1 out of 4. That means the odds of it being unlocked must be 3 out of 4. If the first one is locked, so now this set of branches, so I have dependent events, the probability of the second one being unlocked is 1/3. So the second one being locked is 2/3. So remember, these are complementary events, so they have to make one whole. I'm either unlocked or locked, but they're all different because I'm looking at dependent events. So the probability that both are unlocked, so I'm going to go ahead and use my orange for this one. So unlocked, unlocked. So I can write the probability of unlocked and unlocked is 4/5 times 3/4, which is 12 out of 20. None are unlocked. Well, that's the same as saying both are locked. So let's go both locked. So locked, locked, locked and locked. 1/5 times 2/3 is 2 out of 15. Exactly 1 is unlocked. Well, that's my 2 that are missing here. So I could either use complementary events, or I could find my 2 probabilities. So exactly 1 unlocked, so probability of exactly 1 U, that's going to be 1 minus the probability that I have unlocked and unlocked, or locked and locked. So I could do 1 minus 12 out of 20 plus 2 out of 15. So let's work that out. So I've got 1 minus 12 out of 20 plus 2 out of 15. And let's make that a fraction. And I get 4 out of 15. Or I could say the probability of unlocked and locked, or locked and unlocked. So to do that, unlocked and locked would be 4 out of 5 times 1 out of 4, plus locked unlocked is 1 out of 5 times 1 out of 3. So let's check that out. 4/5 plus 1/4, oh, not plus, times 1/4 plus 1/5 times 1/3. You can see I've got the same answer. So that also gives me 4 out of 15. Okay, at least 1 is unlocked. Well, that's another way of saying that we don't have both are locked. So at least one unlocked is the same as saying the probability that locked and locked didn't happen. So I can do 1 minus, I already know locked and locked is 2 out of 15. That leaves 13 out of 15.